and today I want to talk to you about the other brain. So have you ever heard the statement, you only use 10% of your brain? I know I've heard it a lot from teachers, parents, even my friends, and they always say things like, oh, you have so much potential, if you tried harder you can use more of your brain or something. And they always back up this fact by talking about some article in a popular science magazine, or something that they learned in school, maybe in like first grade, which is really outdated. So we would all like to think that, right? That we only use 10% of our brain, that we have all of this potential that we can unlock in our brains, right? But it turns out, unfortunately, that this 10% myth stems from some really conjectural science made by some old men in the 19th century. So I want to talk to you today about how I found out that I used more than 10% of my brain and what I did with that fact. So basically, one day I was just walking through a Barnes & Noble, and I was looking for some books. And I found this book called The Other Brain. Now this book is basically a really modestly illustrated science book that really explains what the other 90% of the brain consists of. It turns out that this whole 10% myth stems from the fact that only 10% of your brain is made out of neurons, the supposedly true brain cell. And for decades, the neuron has been considered the only true brain cell because it's the only one that creates electrical impulses, right? So glial cells were always considered these structural cells that never did anything. They were considered inert. Basically, because they were considered inert and because they didn't send electrical impulses, they were considered not important in the overall biological processes that the brain had. And this is a picture of glial cells. So basically, the belief that they didn't add significantly to biological processes and higher cognitive thinking led to their almost dismissal in the wider scientific community, and it also led to this whole 10% myth. Now, in the past couple of decades, a lot of new research has come out basically concerning glial cells and their importance in the brain. Due to basically an increase in, better molecular biology techniques and better microscope techniques, people have started to look at not what glial cells can't do and the fact that they don't send electrical impulses, but basically on what they can do. And it turns out that not only do they make up more than 90% of the brain, but they also serve a multitude of really important functions in the brain. So there's three basic cells, three basic glial cells in the central nervous system: astrocytes, microglia, and oligodendrocytes. So astrocytes are these really cool, star-like cells. That's why they're called astrocytes, right? So basically, what they do is they create a matrix for neurons to basically live on. So when you're in the lab and you're trying to make a petri dish of neurons, you really can't grow neurons without having an astrocyte matrix in there first. So obviously they're really important, and they create this thing called the blood-brain barrier, which basically keeps pathogens out of the brain and also keeps some drugs from entering the brain. So it's really important to pharmaceutical companies, because they need to know if certain drugs, are supposed to penetrate the blood-brain barrier or not supposed to. And the next cell is basically microglia, and these cells are the basic immune cells of the brain. I don't know if you knew this, but basically your active immune system, the one that works in the rest of your body, can't really pass the blood-brain, or is not supposed to pass the blood-brain barrier to fight pathogens in the brain. So your brain has these cells to do that function in the central nervous system. And then there's oligodendrocytes, which arguably are or almost the most important. They create the myelin sheath, if you've ever heard of it, on a neuron. And what this sheath does is it insulates the axon of the neuron, and it allows for the electrical signals to basically jump from node to node. And it's actually really ironic that without these cells, these electrical impulses wouldn't be able to be efficiently transmitted, because scientists in the past thought that that was the only important thing, right? Transmitting electrical impulses. So all this research in the past couple of decades has really led to all these new facts about what glial cells do. And it turns out that they're really important, right? Not only in these biological processes, but also it turns out, in higher cognitive thinking. An experiment done, I think, maybe a decade ago, where they dissected Einstein's brain, found that there was a higher glial to neural cell ratio in the part of his brain that was kind of associated with higher cognitive thinking. And actually, I read a few papers maybe a couple of months ago that talked about how glial cells could even be associated with like learning and with abstract thinking. So as research goes on, we could find out that they were implicated in a lot more things. And it makes sense, right? Because they make up 90% of the brain. That's really a staggering number. And then after I found out about all these things in the book, The Other Brain, I decided to do my own research. So I went to a nearby university, West Virginia University, and I asked this researcher, and I was like, hey, can I work in your lab? And he was like, sure, why not? So I spent the next year doing research on astrocytes. And basically what I found out was, I basically found another important role of astrocytes within the whole central nervous system. It turns out that they protect neurons from oxidative stress. So when you turn on a certain pathway in an astrocyte, it keeps neurons from dying from oxidative stress. And oxidative stress is basically stress caused by oxygen radicals, and it can be caused by a lot of different things, like as you can see, by basic metabolic processes, by smoking, radiation, pollution, and that's why antioxidants are important, because they fight oxidative stress. But so what I wanted to talk about basically is that through my research, and both lab-based and literature-based, I found that nothing in science was concrete. Obviously this supposed 10% fact was once touted as a scientific fact, but it wasn't true. So everything in science really is just like a qualitative interpretation of a data set, or a quantitative interpretation of a data set, or a qualitative interpretation of a natural phenomenon. Science itself is based on theories, right? Tested and retested theories that are open to being broken down by new information. And if there's one thing I want everyone to take away, it's that you shouldn't accept everything touted as a scientific fact. Because science is not a body of facts. It's a method of inquiry. Sure, we as a society have really built up a really huge, like a vast amount of facts using this method, but it doesn't mean that every single fact is right. So next time someone tells you that you only use 10% of your brain, please tell them what I told you, and remember, question everything. Woo!